Question number 19, worksheet forces on threaded ring. A particle P of mass 1.6 kg is suspended in equilibrium by two light inextensible string attached to point A and B. Okay, first of all, I'm going to draw the weight downwards. Weight is mg, so 1.6 times 10, which is 16 newtons. Okay, these are two strings, and this one we can call T1, and this tension in the string we're going to call T2. We know that the direction of tension is always away from the mass. Okay, and we need to find the values of tensions in the two strings, and the angle that the strings make with the horizontal are shown. Okay, so now since there are only three forces acting on P, instead of resolving the forces, I'm going to use Lemmy's theorem. I hope you remember what that is. It is T1 upon sine of the opposite angle. This is that angle. Let's call it theta1. And T2 upon sine of the opposite angle, which would be this angle. Let's call it theta2. And 16 Newton, which is the third force, upon sine of its opposite angle. I know what this angle is. For now, let's call it theta3, sine theta3. Okay, how do we know what's this angle? We're just going to do 180 minus 20 minus 40, which is what, 120. So this is going to be sine 120. Okay, we have this angle. We also have the other two angles. So if we use alternate angles, then this angle here would be 20, and this angle here is 90. So 20 plus 90 is 110. So T2 upon sine 110 is equals to T1 upon, again, use alternate angles, and that would make this angle 40. So 40 plus 90. 130. So we have sine 130 here. Now we're going to use the first fraction and the third fraction, get T1, and use the second fraction and the third fraction, get T2. I'm writing the answers directly. T1 rounded would come out to be 14.2, and T2 rounded would come out to be 11.4.